Welcome back to our lecture series on resistor. So in this part of this video, we are going to be talking about resistor connection. So if you are new here or you missed the previous part of this video, I'll drop a link to the previous part of this lecture series under resistor. You'll find it in the description of this video. Just go to the playlist on electrical engineering. You're going to find them there. Alright, so now let's talk about the resistor connection. That is the different ways in which resistors are being connected. So basically there are just two. We have the series and the parallel connection. So now let's start with the first one, which is the series connection. So you can have it as the series connection or resistor connected in series. So by definition, so resistors are connected in series when they are connected end to end. So let me write it down. So it says the resistors are connected in series when the terminals are connected end to ends. So now let's put this in diagram and show you. Let me show you what it looks like. So if we have one resistor like this, remember this is one terminal, this is another terminal. Are we good? So then another resistor again. Exactly. So it can continue like that as many as possible resistors that you want to have in that particular circuit. So this is R1, which is our first resistance, our first resistor. Then this is R2, this is R3. Are we good? So you can, if you look at it, this is like in the definition we gave earlier that a resistor is a two-terminal device. So this is the first terminal for the R1, and this is the second terminal for also for R1. So you can see that this terminal is connected to this other for that of R2. So let's go back to the definition. So resistors are connected in series when terminals are connected end to end. So the end of one terminal is connecting to the end of one resistor is connecting to another resistor, and it continues like that. So that is it for series resistor. Exactly. So now what I want to do now is let's reduce this to two resistors so that we can also look at some other things that has to do with resistors when they are connected in series. So that's talking about the equivalence or the total resistor of a resistor. The total resistance of a resistor connected in series. Are we good? So in doing that now, with the diagram that we have on screen now, we know that this is R1 and this is R2. So how do we find the total resistance of this entire setup? Exactly. So you can call it the total resistance or the equivalent resistance. Okay. So if we have current flowing in this direction, and then we have current flowing in this direction. So another thing you also need to take note about series connection is that if you have a series connection in terms of a resistor connected in series, the current that is flowing through R1, if the current here flowing through the first resistor is also the same thing with the current that will flow through the second resistor. So that means you can also say that for a series connection, the current flowing through each of these resistors are the same thing. That is when we are dealing with series. So you might need to also take note of that the current flowing through a series connected resistors are equal amount of current flow through them. However, but the voltage are different. So if the voltage flowing across this V1, this R1 resistor is V1, the voltage across the R2 resistor, let's give it V2, they are different. Exactly. There will always be a voltage drop as it goes along that particular resistors. Okay. However, the equivalent resistor, the equivalent voltage or total voltage, let's represent that as V. Are we good? So if you put them together, that's V1 and plus V2. So that means V1. So that means V1 plus V2 is equals to V. Are we good? So again, a summary of what we have on screen is that this is our R1 and R2, which is the first resistor and the second resistor. And like I said, in a series connected resistors, if you have resistors connected in series, the same current flow through each of those resistors. Exactly. The current through this one is, so if let's say if a 5 amp current is flowing through this resistor, the same 5 amp current will flow through the second resistor. However, the voltage will not be the same thing. Exactly. So if the voltage flowing through this place is, let's say, 5 volts. Exactly. So it might get here and then it becomes 4 volts. So they are always different. But if you add them up, it will give you what we have here as V. So that's why we're having V1 and V2. So now let's now use this analysis to calculate the equivalence or the total resistance of these two resistors when they are connected in series. Exactly. All right. So now from Ohm's law, we know that V is equals to IR. Are we good? Okay. So that means we can say that our V from here, that means our V1 plus V2 is equals to V. So let's just call this our equation 1 and let's call this equation 2 so that we don't mix everything up. Now, if we should substitute the value of V for each of the resistors, so that means for this particular V1 now, from V is equals to IR, so that means, let me write here that at resistor 1, so at resistor 1, the voltage, which is V1, consider as V1, will be from Ohm's law, which is IR, which is I times R1. Exactly, because that's it for R1. We know that the current, this is the current, so that means V1 here will be R1 times I, and then at resistor 2, that will be V2 will be I times R2. Remember that I said earlier that the current that is flowing through all of the resistors when they are collected in series, they are the same thing. Okay. Then for the entire circuit, in a combination of the R1 resistor and R2 resistor, the voltage across it also will be V is equals to IR, where R is the equivalent resistor. The equivalent resistor. So let me just write as IEQ. So you can write it as IEQ or R total. So that means we now have IR is equals to, so coming from here, where we have our V is equals to V1 plus V2, and we've gotten our V1 to be this and our V2 to be this. So we can say IR is equals to IR1 plus IR2. Okay, so if you look at it, we are having IR is equals to, so since I is common, so you can say I into brackets R1 plus R2. Okay, so now we can divide both sides by I. So in doing that, so let me write it. So we are having IR over I plus, equals to I into brackets R1 plus R2 over I. So this can cancel this can cancel this. So with that means our R is equals to R1 plus R2. And that's how you can derive the expression to get the equivalent resistor, the equivalent resistance of resistors connected in series. Exactly. So this my R here is the same thing as my R total or R equivalent. You can write it whichever way that pleases you. So in case you come across something like this, so I'm still saying the same thing. Exactly. So that's how you calculate the equivalent resistance for resistors connected in series. So it's the same step you are going to use even if the resistors are more than 2. For instance, in this example now, we use only 2 resistors, even if it is 3 or 4. So what I'll just encourage you or advise you to do is practice with 3 and 4 to see what you are going to get. So if it is 3 also, you're going to get your R to be R1 plus R2 plus R3. Exactly, that means your R total. So if it is R4, it will be R1 plus R2 plus R3 plus R4. That means if you have 4 resistors connected in series. So I'll just encourage you to try that yourself and try to get the answer. And the reason why I'm saying it is so that if you come across it in an exam and you're asked to derive an expression for 4 resistors connected in series, derive an expression to get the equivalent or the total resistance of 4 resistors connected in series, so you won't have problem. Because most questions will not ask you to find that of 2. They won't ask you to find one. They always start from 3 and above. Exactly, because it can be a little confusing. But if you understand this, and that's why I want you to take it as an assignment and then do that. So that is it on that series connected resistor. So another thing I want to mention is about the series resistor is that, like I said, the current that is flowing through them will be the same thing, but the voltage are going to be different. There's going to be voltage drop. So another thing about series connected resistor is that if one resistor goes bad, it affects the entire circuit. Exactly. So if you have a circuit like this now, this is just to, if anything goes wrong, let's say this resistor got burnt. Exactly. That means there will be a stop or there will be a disconnection in the circuits. So that's one other, should I say, disadvantage in series connected resistors. Exactly. So you also need to take note of that. So that's just another point there. So I haven't talked about series now. Let's go ahead and talk about parallel. For that of resistors in parallel, I'll be doing that in a separate video. So I don't want this video to be too long. So I'm doing that in a separate video. So like I do end my video, if you have any question, any comments, do let me know in the comment section below. So with that now, let's go ahead in the next part of this video to continue with resistors connected in parallel. Thank you.